As we've been talking about, the blockchain is like another layer to the internet that enables secure, trusted records and transactions between people who may not otherwise trust each other. The trust is in the technology, computer code and mathematics, rather than people and centralized institutions. In this respect, people sometimes talk about the blockchain as a trust machine in its capacity to enable a network where trust is created by design. It's built into the system automatically. Because the blockchain creates a trusted database, it can function as a record of value storage and exchange. These records of value and transactions may be called ledgers. Since ancient times, ledgers have formed the backbone to our economies, to record contracts and payments for the buying and selling of goods or the exchange of assets like property. These ledgers started out as records in stone, clay tablets and papyrus, and later paper as they evolved into the ledger books supporting modern accounting. These ledgers enabled the formation of currencies, trade, lending, and the evolution of banking. Over the last couple of decades, though, these records have moved into the digital realm, as whole rooms of people working to maintain accounts have been replaced by digital computers, which have made possible the complex global economic system we live in. Today, this record-keeping system is once again being revolutionized, as these ledgers are shifting to a global network of computers which is cryptographically secured, fast and decentralized, what we call distributed ledger or distributed ledger technology, DLT for short. A distributed ledger can be described as a ledger of any transactions or records supported by a decentralized network from across different locations and people, eliminating the need of a centralized authority. All the information on the ledger is securely and accurately stored using cryptography and can be accessed using keys and cryptographic signatures. Any changes or additions made to the ledger are reflected and copied to all participants in a matter of seconds or minutes. The participants at each node of the network can access the recordings shared across the network and can own an identical copy of it. At the same time, these networks make constantly available for examination a full audit trail of information history, which can be traced back to the moment when a piece of information was created, and every participant in the network can get simultaneous access to a common view of the information. These ledgers can be used for the recording, tracking, monitoring, and transacting of all forms of assets. All asset registries, inventories, and exchanges, including every area of economics, finance, and currencies. Physical assets such as cars and houses, and intangible assets such as votes, ideas, health data, reputation, etc. In this case, the blockchain can serve as a public record repository for whole societies, including the registration of all documents, events, identity, and assets. In this system, all property could become smart property. This is the notion of encoding every asset to the blockchain with a unique identifier such that the asset can be tracked, controlled, and exchanged on the blockchain. For example, distributed ledgers could be used to replace or supplement all existing intellectual property management systems, as they can register the exact content of any digital asset, such as a file, image, health record, or code, to the ledger and give it a unique identifier in the form of the hash values that we discussed earlier. There are two main classes of distributed ledger: public ledgers and permission ledgers. The former type is maintained by public nodes and is accessible to anyone. Bitcoin is a well-known example of a public blockchain where anyone can read the chain, anyone can make legitimate changes, and anyone can write a new block into the chain. Ripple is an example of a permission blockchain, where the creators of the network determine who may act as transaction validators on that network. Distributed ledger platforms in each category have their own unique features. Some are designed for specific types of application, and others for more general use. For instance, in the Corda DLT platform, which is a consortium of more than 70 of the world's largest financial institutions, the sharing of individual ledger data is limited to parties with a legitimate need to know, which is not the case for public platforms. DLT technology can have a powerful disintermediation effect, as data can be put directly onto the shared database by the nodes in the network. There is no longer need for a centralized organization to provide this service. A developer can create a DLT on a blockchain and use public-private key cryptography to give people secure storage space on that ledger, allowing people to own their own data, which creates a very different scenario to the world we live in today. Currently, centralized organizations like Google and Facebook suck up all of the little bits of data we leave behind us and use it to serve us customized advertisements from which they create their revenue. This results in a huge power imbalance within society, where centralized organizations, armed with teams of mathematicians and computer scientists, use mountains of data to influence people's behavior towards purchasing the products of their advertisers. Data that is a very valuable asset in an information society and of critical importance to tackling major societal challenges is being used against us in many ways, creating a stumbling block that societies are becoming increasingly aware of. In a world of distributed ledgers, people have their own little databases on the blockchain and can own their own data, giving it to organizations to use when and where needed, fundamentally reversing the current dynamic and truly empowering individuals. Your health records reside in your health ledger, and different healthcare providers can access and update that single record, but only with the permission of the end user, as the data remains theirs, and they choose who can have access to it. Likewise, when people own their own data on a distributed ledger, they can transact directly peer-to-peer, as is the case with Bitcoin. With the existing traditional system, when you pay for a ride in a taxi with a credit card, it looks like you're paying the driver directly, when in fact, what is happening is that a database record belonging to my bank is being debited and a database belonging to the bank of the company that the driver works for is being credited. In this respect, we can note that in our society, value and data do not really belong to individuals. All the time, they're being held behind the walls of some centralized organization, and we are dependent upon them to secure and validate it, creating huge power imbalances within society. In contrast, with the Bitcoin blockchain, the individual has a ledger record and a secure key with which they can access their record. When they send money, they send it directly to the other person's record. It simply gets debited from your record and added to theirs directly, peer-to-peer. No centralized organization holds that data. Distributed ledger technology can greatly improve transparency, reduce corruption, and improve security while reducing overhead costs of auditing, accounting, and legal issues. Currently, records of value are hidden within the databases of centralized organizations, where they're largely inaccessible for their many possible uses within other systems. They are open to manipulation by members within those organizations, which breeds corruption. And because of that, there has to be all sorts of regulation and legal requirements that create many overhead costs. Added to this, they are centralized points of failure for critical data sources, as large concentrations of valued data prove very attractive for malicious actors. Likewise, it is inefficient to be constantly updating and synchronizing data across many centralized databases. By putting the information on a shared ledger, it can be easily made accessible and visible on demand as needed. Because it is tamper-proof, we can remove many existing points of corruption and the associated need for regulation. Likewise, it is made secure by distributed networks without a single point of failure and continuously synchronized across all nodes to create a single source of truth for all users.